Hello everyone, this is Chaitra, guest lecturer, Department of Mathematics, ADB First Grade College, Harapanadi. Dear students, in this class, I am going to explain about the Cauchy's sequence. First, let us know about the definition of Cauchy's sequence. Definition is a sequence xn is said to be Cauchy's sequence if for a given epsilon greater than 0, then there exists a positive integer value m such that modulus of xm minus xn is less than epsilon. Here, in this definition, is sequence xn is said to be Cauchy's sequence if for a given epsilon greater than 0, then there exists a positive integer value m. Here, the epsilon value is corresponding to a positive integer value m, and the difference between the xm and xn is less than epsilon. That epsilon value should be positive integer value for all n greater than or equal to m. That epsilon value is greater than 0, that should be a positive number. Theorem related to the Cauchy's sequence. First, the statement of this theorem is every Cauchy's sequence is bounded. Already we have seen the definition of Cauchy's sequence. Now I will explain about the definition of bounded. Theorem statement is every Cauchy's sequence is bounded. Now bounded definition is if a sequence xn is said to be bounded, then it is bounded above and bounded below. If a sequence xn is said to be bounded if it is both bounded above and bounded below. That is, if we tell a sequence is bounded is nothing but it should be both bounded above and bounded below. Then what is meant by bounded above and bounded below? First, let's see bounded above. If a sequence xn is said to be bounded above, then xn is less than or equal to small l. If a sequence xn is said to be bounded below, then xn is greater than or equal to capital L. Then if we write in a proper way, L is less than or equal to xn less than or equal to capital L. Then we can tell xn is bounded. By this, now we have to prove the theorem every Cauchy's sequence is bounded. Now let's see the proof of this theorem. Let xn be a Cauchy's sequence. Let xn be a Cauchy's sequence for a given epsilon greater than 0. Epsilon for a given epsilon greater than 0 I told. Here I will choose the epsilon value will be 1. You can take epsilon value any number that should be positive value because greater than 0 I have told beginning epsilon equal to 1. By the definition, now we can tell there exists a positive integer value, that is modulus of xm minus xn is less than epsilon value is 1. Less than epsilon should be right. Here the epsilon value I had chosen 1. Now apply the mod condition, then xm minus xn, the mod number will be less than 1 and greater than minus 1. Here the mod value is less than 1 and greater than minus 1. After this, add xn on both sides. Xn minus 1 plus less than xm minus xn plus xn is less than xn plus 1. Here minus xn and plus xn will be cancelling. Remaining terms xn minus 1 is less than xm less than xn plus 1. Here xm is less than xn minus 1 and xm is less than xn plus 1 and xm is greater than xn minus 1. Now what are the terms in the sequence? Suppose small l equal to minimum of the terms in the sequences x1, x2 and so on, xn minus 1, xn plus 1, and capital L equal to maximum of x1, x2 and so on, xn minus 1, xn plus 1. Now this can be written as L is less than or equal to xn less than or equal to capital L. That means upper bound xn is less than or equal to capital L and lower bound xn is greater than or equal to small l. Now we can tell xn is bounded. That is Cauchy's sequence is bounded. This is the proof of this theorem. This is all about Cauchy's sequence, and this is the syllabus which I had left for BSc second year students. And I circulated the notes to you. One who don't get the notes, you can get from me. Stay home, stay safe. Thank you.